Okay, this next one is about the leading coefficient test. And the leading coefficient test is really a big deal. As trivial as the last video seemed, this one is really going to do something to help us out on these graphs. All right, so what I want you to notice first is a very distinct difference between the graph of x squared versus x cubed. And that is, the x squared graph points in the same direction on each side of the vertex. The x to the third graph does not. They point in opposite directions. That's kind of a big deal. The reason it's a big deal is because that's true of any even power versus odd power graph. All right, if it's an even power, see the arrows going in the same direction. That's the way it's going to be for any even power in a graph. They're both going to go in the same direction, whether it be up or down. Okay, as opposed to an odd power where one side goes up and one side goes down. It's going to be true for all of them. Yes, this is a characteristic shared by all polynomials. All right, so we're going to want to write this down. If the highest degree is even, then the extremes point in the same direction. What do I mean by the extremes? I'm talking about the graphs as they approach positive and negative infinity in the x direction. All right, so as the graphs go further and further outwards, left and right, the curve of the graph is going to be heading in the same direction. I mean, there's all kinds of things that can happen in between. You could have an even power that looks like this, but in the end, it's going to be going up again just like it did on the other side. If the highest degree is odd, then the extremes point in the opposite direction. All right, let's take it a little bit further. This is a good indication or a good snapshot of what the leading coefficient tells us. All right, even degree, like x to the fourth, odd degree, like x to the fifth. If the coefficient is positive, they're both going up. Okay, let's take them one at a time. Okay, if you have an even degree and a positive coefficient, both sides are going up. All right, and the way we notate some things is this: as x approaches positive infinity, that means as x goes in that direction, f of x goes to positive infinity. F of x is just y. So as x goes further and further to the right, the function's going up. As x goes further and further to the left, the function again is still going up. If it's a negative coefficient, as x approaches positive infinity, y approaches negative infinity. Y goes down. And as x goes further to the left, to negative infinity, y also goes down again. Even degree, negative coefficient. So for example, negative 6 x to the fourth. That's an even degree and a negative coefficient. Okay, you could have a whole bunch of other stuff on there. You could have negative 6x to the fourth minus 2x to the third plus 9x squared and so on. But that first thing right there tells you all this. We can deal with this stuff later. That first term, the leading coefficient and power, tells you everything you need to know. Okay, odd degrees. Okay, they go in opposite directions. If it is a positive coefficient, an odd degree, so let's say you had positive 3x to the 7th. You know this. You know it's going up in that direction and down in this direction. Regardless of whatever else comes after it, you know this. And lastly, an odd degree with a negative coefficient. For example, a negative son of a gun. For example, a negative 2x to the 25th there. Odd degree, negative coefficient, regardless of what comes after, you know it's going to do this. All right. That's all you need to know about the leading coefficient test, guys. See you next time.